Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about the transconductance of MOSFET. This is GM, what we call transconductance, and the extraction of formulas for this parameter. This is a typical formula for GM, but we have two other formulas as well, and I'm going to prove it for all you. But be careful, the transistor must work in saturation region so that we use this and we define this parameter. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button, and also the notification bell, so whenever I upload a new video, you'll be aware of it. So here, this is an NMOS transistor, and we use, this is actually gate, this is drain, and this is source. And we're going to use this simple model for a small signal. This is called VGS, and this is called GMVGS for this NMOS transistor. So this is gate, this is source, and this is drain. We use this simple model for a small signal, and what we're looking for in this particular video is to how we can define this parameter. This parameter defines when the transistor works in saturation. So the condition of saturation is satisfied, which means that the gate source voltage of MOSFET is greater than V threshold, and also the gate drain voltage of this transistor is less than threshold voltage. So the drain current for this region is defined as 1 divided by 2 mu n C oxide W over L times VGS minus V threshold to the power of 2. Now we define this parameter GM, which is called transconductance. Why we call it transconductance? Conductance is something that is related to the current divided by voltage. So why not call it just conductance or admittance? Because the current is in the output, which is the drain current, and the voltage is in the input, which is gate source voltage. And we call it like this: round ID divided by round VGS. We get the derivative of this function with respect to VGS. What does that mean? It means that all the parameters in this formula are constant except VGS. We assume that the VGS is variable. So now I'm going to take the derivative of this drain current with respect to gate source voltage. What is the derivative? These are all constant, but this one is variable. So as you remember from your high school, 2 going to the behind of this formula times 1 divided by 2 mu n C oxide W over L, these are all constant, times this parenthesis VGS minus V threshold to the power of 2 minus 1, which is 1. And these two are cancelled out, and we have left with this formula for GM. This is the basic formula for GM, but we have other two formulas as well. Look at this formula. You can calculate VGS minus V threshold with respect to other parameters, which means that VGS, I can write it as this one: VGS minus V threshold is equals to 2 times ID divided by mu n C oxide W over L, and just take the square root of both sides. So we have this. And if I put this VGS minus, I substitute this VGS minus V threshold into this formula, I can get a second formula for GM. So How I'm going to do that? Here is the basic formula for GM, mu n C oxide W over L times VGS minus V threshold. And now I'm going to use the formula that I calculated. So here we have mu n C oxide W over L times, what is VGS minus V threshold? It's square root of 2 times ID divided by mu n C oxide W over L. So this parameter, just we can call it, for example, K divided by square root of K. So all we have left with a square root of K on the denominator. So the second formula for GM is going to be square root of this 2 mu n C oxide W over L times ID. This is the second formula for GM. How about the third one? Because I already told you we have third formulas for GM in saturation region. Again, look at this formula for ID in saturation. 1 divided by 2 mu n C oxide W over L times VGS minus V threshold to the power of 2. Now I can calculate mu n C oxide W over L with respect to other parameters. So what do we have? We have 2 times ID divided by VGS minus V threshold to the power of 2. Now I'm going to substitute this into this formula. So we have GM, just instead of this one, I'm going to use this formula. So we have 2 times ID divided by VGS minus V threshold to the power of 2 times VGS minus V threshold. So one of them is cancelled out and we have left with 2 ID divided by VGS minus V threshold. Just to recap this video, we have 3 different formulas for GM, and based on the problem that you have faced in CMOS amplifiers, you can use either of them. We have the main formula, which is exactly the definition. What was the definition? The definition is this one: round ID divided by round VGS. And always try to bear that in your mind. This is the main formula, this is the basic formula, and try to just prove it for yourself. This is really helpful for you to learn this and commit this into your memory for always. The definition is the key. So the main formula is this one: mu n C oxide W over L times VGS minus V threshold. The second, what was the second formula in the video? Square root of 2 times ID mu n C oxide W over L. Here we substitute VGS minus V threshold with respect to other parameters in drain current formula. And the last one, 2 times ID divided by VGS minus V threshold. And in the last one, we substitute mu n C oxide W over L with respect to other parameters in the drain current formula in saturation region. And always remember that the transistor has to work in saturation, so we can define this GM formula, these 3 formulas for GM, not in a triode region. Be careful with that. Okay, I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friends. See you in the next video. Thanks for watching.